Today we are going to look at 7-5 Part 2. Now, last time in 7-5 Part 1, we dealt with solving exponential equations. Today we're going to have logarithmic equations. So, the problem that you see right here, that's the type of problem that we're going to take a look at today. Okay, well, let's get started. Here is the definition for a logarithmic equation. So it says, a logarithmic equation is an equation with a logarithmic expression that contains a variable. Alright, so you have a logarithmic expression here, and a logarithmic expression here, and you put an equal in the middle, and you're going to solve that. Now, something I want you to see. If log of x base b is equal to log of y base b, notice the bases are the same. That means x must be equal to y, as shown right here. Okay, let's begin today by reviewing. Last time, I gave you something like, let's say I gave you 2 to the 3x equals, say, 2 to the 6th. And your task was to ask yourself this one question. Do you see a log anywhere in there? Do you see the word log over here or log over there? If you do not see the word log, you're going to put it in there. So I'm going to go log of 2 raised to the 3x is equal to log 2 to the 6th. Now, what was the base of the log that I wanted to use? Well, what's the base of the exponent? A 2. Yes, and over here it's a 2 as well. I'm concerned about this one because I want to get this 3x by itself. So, the log that I'm going to take of both sides was base 2. Now, by doing that, we found that this logged out. And it left me with 3x is equal to, and it just so happens this logs out as well, and we were able to get x equals a 2 for an answer. Now, today we're going to do something very similar to this. However, you're going to ask yourself the same exact question. Look here. Do you see a log? Yes, I do. I see a log right there. So since you see the word log, we're going to do something called exponentiation. We're going to rewrite it and we're going to exponentiate it. In other words, we're going to rewrite it so that we can get the base of the exponent being the same as the base of this log right there. Okay, so let me show you. Let's uncover this. And that. Okay, so notice what we've done. The base of the log was 6, so I wrote it as 6, and then I put the whole thing up as the exponent. Same thing over here. Whatever you do to one side, you do to the other. Now, by doing that, notice what happens. By the inverse property, they log out, leaving us with, and you're going to have 2x minus 1 on one side, and 6 to the negative 1, which is the same as 1 over 6 on the other. Now we're going to add 1 to both sides, and then we're going to divide by 2, so I get 2x is equal to 1 and 1/6. Then I divided both sides by 2, and for my final answer, I got x equals to 7/12. Now, don't stop there. Make sure you check your answers, and if it checks out, put it in set builder notation, and you're done. Okay, so in a nutshell, what did I tell you to ask yourself? Anytime you look at a problem like what we did yesterday or last time, or like a problem we're going to look at today, ask yourself the one question. Do you see a log? If you do not, you put it in there. And over here, if you do see a log, you take it out of there by using exponentiation. For this example, we are going to do the same thing, but we need to do something first. I want you to notice, do you see this minus sign? You do not want a minus sign and 2 logs in there. You need to condense it. So you're going to use your quotient property of logs, and you're going to condense it. Now remember, subtraction means division. So we have log base 4 of 100 over x plus 1 equals to a 1. Then you're going to ask yourself, do you see a log? Yes, you do. So what are you going to do? You're going to get rid of it. And how are you going to get rid of it? You're going to exponentiate it. That means you're going to take the same as the base of the log, and you're going to raise it. So it's 4 raised to that log, and what you do to one side, you do to the other side. Now, what's going to happen? Well, right here, this is going to log out, and you're left with, over here, 100 over x plus a 1 equals to a 4. Now, you're going to solve this. Remember, this is a proportion. So we want to cross multiply. And when you cross multiply, you're going to end up getting, so let me come right over here and finish this out. So you're going to get 4 times the quantity, x plus 1 equals to 100. Now, you have two choices. You could either distribute the 4 inside, or you could divide both sides by 4. I'm going to do that. It's quicker and easier. So I can see now that I'm going to subtract 1 to both sides, and I'm running out of room, so let's go this way with it, and I will get x is equal to, yes, that right there. So now we just put it in set builder notation, and remember, always double check to make sure it works by doing what? You said it, plugging it in to check. Okay, let's go do another example. Okay, for this problem, it shows us, well, just look at it. Ask yourself, what question? Correct. Does it have a log? Do you see a log? Yes, you see the word log. So that means you need to get rid of it. And you're going to do that by exponentiating. But we have to do something first to prepare this. Do you see this little 4 right up there? I'm going to take that 4 and I'm going to pull it out front. Okay, what property was that? It's called your power property of logs. That is correct. Okay, so let's get rid of this here, and you have 4 times the log of x base 5 equals x. Now what we're going to do is you're going to divide both sides by 4. And after dividing both sides by 4, you're going to get log of x base 5 equals a 2. Now, we've simplified it down to this part of it right there. Now, ask yourself, do you see a log? Yes, you do. So you're going to exponentiate it. So you are going to rewrite it so that you have a base of the exponent being the same as the base of the log. So it's 5 raised to log of x base 5 equals 5 to the second power. Now, over here, what do you see happening? Well, you see it logs out, leaving us with just 1x there. And of course, you get a 5 squared on the other side. All right. Now, what's 5 squared? Yep, you said it, 25. And there's your answer. So, now, remember, go back and check, make sure that works. If it all works, put set builder notation around it, and you have it. All right, folks, now let's look at the fourth example. Now, in the fourth example, do you see what's here? You see a plus. You see a log plus another log. Now, I tell you right now, just so you know, anytime you see more than one log on one side of the equal sign, you're going to have to do something to compress it. Now, what did I just say? What I just said is something you need to make in a little asterisk in your Cornell note and put that off to the right, or I'm sorry, to the left. So, let me say that again. If you have an equal sign and you see more than one log, you see the word log, log on one side, what you have to do is you have to make it so it has one log. Okay, so anyway, let's go ahead and do that. So here, we're going to combine this, making it, I see plus, so that means I'm going to use my product property of logs. Combine it. Now, remember, addition means what? You are correct, multiplication. So it's going to be x times x plus 1. Now, next question, ask yourself, do you see a log? Yes, you do. So what do? Get rid of it. And how do you get rid of it? exponentiate it. So you rewrite it so it looks like this. All right, now, what's going to happen here? Well, at this point, you see that these are going to log out, leaving us with x times the quantity, x plus 1, equals to a 12. All right, now, what do we do from there? What does that look like? Well, hopefully you recognize, you need to get rid of parentheses. You're going to distribute in your x. And once you do that, that means you're going to have a quadratic equation. So notice here, let's go ahead and do this here. So we have x squared plus an x equals to a 12. Since it's quadratic, you have to set it equal to, that's correct, 0. So you can have x squared plus an x minus a 12 equals to a 0. Now, how do you solve a quadratic equation? And many of you right now are thinking, okay, what do we do? Yes, you're right. We're going to factor it. Then we're going to use the zero product property, set each one of those factors equal to 0, and solve for x. All right, so let's go to the next slide, and let's show us how we're going to do that. Okay, so here we are, all ready to go. So let's go ahead and do this. So the first thing we're going to factor it. What are the factors? Now, first of all, ask yourself this question. Is there a greatest common factor? No, there's not. Since there isn't a greatest common factor, does it have 2 terms? No, it doesn't. Does it have 3 terms? Yes, it does. That means you're going to tree it out. So let's tree it out. What factors of negative 12 are going to give us a positive 1? And you're saying yes. X minus 3, x plus a 4. Now we're going to use a zero product property. You're going to set each one of those factors equal to 0 and solve. And when you do that, you get x is equal to a 3 and x is equal to a negative 4. Now, you might think you're going to get 2 answers, but you might not. Take it and plug it in. So let's first plug in the 3. Now notice here when I plug in the 3, simplifying this, get down, and what happens? Voila, it works. It comes out a true statement. All right, so we know 3 is a solution. So now let's plug in the negative 4, and notice what happens when you plug in the negative 4. When you plug in the negative 4, you can't take the log of a negative number. That is undefined. Therefore, your solution is just x equals 3. Now, don't forget, put your answer in set builder notation. On this slide, it's given us a real big warning. What kind of big warning is it giving us? Well, it's telling us we need to be careful, be cautious. Plug your answers in. Make sure they work. All right. We're getting close to being done. But let's go to the next problem. Take out your graphing calculator. You can use your devices if you want, and we're going to go through a couple problems where we're going to solve these using our calculator. In this slide, we are going to use tables and graphs to solve exponential and logarithmic equations and inequalities. Now, for this problem here, what do I have? Well, that right there says it's an inequality. Okay, so what we're going to do is we're going to take our graphing calculator, and for L1, and I'm going to explain it as if we're using, like, for example, our Inspire or your 84. Okay, so you're going to enter your first equation, and we're going to enter one of these in for L1, for f of 1 if you have an Inspire. Okay, then we're going to enter this in for L2 or f of 2 if you have an Inspire. Okay, now, so we're going to enter this in. Okay, so let me get rid of this first blue block here. All right, so that's what we've done first of all. Then secondly, you're going to hit graph. Now, when you graph it, let's slide this off a little bit, it's going to look just like this. Now, what we want to see is, I want to see right here, you look at that right there, I want to see where the one equation, which is going to be 2 raised to the x plus 1, is going to be greater than 8192x. Okay, now, this equation right here is the linear equation. That's the 8192. This one here is the 2 raised to the x plus 1. Where is this equation greater? Right there it is. So, take your calculator and I want you to trace one of the graphs until it comes to a point where they get right there and they touch. Now, they're going to touch, or they're going to intersect, when x equals 16 and y equals 131,072. All right, now, what does that mean? Well, that means that when x is greater than 16, you're going to have this equation larger, greater than this equation. Okay, now that's how you see it using the graph. Now, let's go ahead and let's look at how it's going to look if you looked at the chart, the table. Okay, if you look at the table, notice here, you're going to see right here at 16, you see them being the same. And then anything above 16, you're going to see y1, and remember y1 was the 2 raised to the x plus 1. It is greater than y2. Okay, so what does that mean for our answer? Well, it means that the solution is x such that x is greater than a 16. Okay, let's take a look at another one. Now for this one here, this is what you're going to do. You're going to take this part of the equation, plug it in for y1, take this part of the equation, plug it in for y2, and we want to know when they are equal. That means when they're going to do what? If you said where they're going to intersect, you're correct. And the x value where they intersect is our solution. Alright, so let's go ahead and uncover this. So, right here, I uncovered, we plug that in, we already stated that. Alright, so let's see by looking at the graph just what's it going to look like. Okay, looking at the graph. Okay, that way is the chart, here's the graph. Okay, so here we go. I have my first equation going this direction. My second equation running this direction. Where do they cross? They cross at x equals 30. That means my solution is 30. Now, let's go ahead and clear this off so we can look at the chart, or the table I should call it. So looking at the table, when x equals 30, I'm at 2 for my range values. So that is my solution. So make sure you put your answer in set builder notation when we're all done. So it's going to be x such that x equals a 30. And that pretty much wraps it up. Our assignment for today is right here. So go ahead and write down this problem set right here. And I will see you in class.